All right, well, we'll get started. What do you guys want to do today? So the lesson goes over the last part of finishing up the linked list implementation, or at least a piece of it. So we actually do one of the trickier bits where we look at how to remove an item from the list, and you guys get to do add as today's homework problem. So happy to take questions. Probably best use of our time today would be for me to address some of the questions that you guys might have. So start them coming in the chat. And then the big takeaway here. The other thing that I want you to absorb, and we'll ask about this in the future, is thinking about the relative performance of these two types of lists. So at some point. We want to be able to reason about performance at sort of a higher level. We want to be able to say, think about the operation sort of in the abstract. When we're getting started, it can be helpful to actually use code to look at how things work, right? And to think about performance. So, when we go through this and we look at our get and our set methods, right? They're now both using this walk to function that we added. But still, that walk to function we can see is going to have to actually walk the list to the right spot. And so that produces an ON performance for both of these. However, when we think about add and remove, this special case of add that we've already completed, that we needed to actually get the constructor to work so that we could create these and start to mess around with them, that's a single operation. I have to create the new item. But after that, I'm just sort of moving some references around. And so this special case of add, where I'm adding at the front of the list, turns out to be quite fast. And for some applications, this is not the special case. There are applications that you're going to write in the future that use a list-like data structure, but really, only or largely manipulate the end of the list. So there are certain applications or certain programs you're going to write that will keep a series of items sorted in some sort of order, right? But only tend to, maybe remove things from one side, add them to another, or maybe add and remove from the ends. You might sometimes need to get into the middle of the list for certain reasons. But if most of the activity happens at the start and the end of the list, that's why we have this linked list class hanging around in Android, because it can perform better in those situations. So, one of the easiest examples for me to come up with are usually things that are connected to the class. So if you think about the help queue that we use as part of the help site, that's an example of a place where, when you come in and you sign up, we're putting you at one end, and the staff are mostly working from the other end. We give them the option sometimes of dipping down a little bit past the person who's at the very top, because sometimes it's better to keep staff working with the same student multiple times, and so that's really up to them. But really, they're kind of typically choosing students that have been waiting the longest for help to help next. So we bring in people at one end, you take them out at the other. Now, the application still sometimes needs to manipulate parts in the middle of the list. Like if a student leaves, right, we have to make sure that we remove them from the list. And so we still need access to the inner parts of the list, but most of the operations on that list happen at either the front or the back. And so, we use a list-like data structure to maintain that information. And again, there's actually, you guys will learn about, a list is on some level the most general form of this particular type of data structure. In future classes, you'll learn about something called an actual queue, which only allows me to modify the two ends. And then something called a stack, which is even more limited and only allows me to modify one end. These were actual data structures that people use for actual programs, because there are certain cases where they're actually really useful and they solve a problem well. But sometimes those data structures don't allow you to manipulate the middle part of the list at all. Right? I mean, the only operations that I can perform are on the front and the back. And so for our office hours system, that's not sufficient, because sometimes we need to kind of peek into the middle of the list. But most of the operation, most of the action, again, happens at the ends. All right, let's get some questions going. Yeah. Yeah, absolutely. You can, yeah. So there's definitely like and that's what you would want, right? You would want, and so the question is, can I, if I have a list that has fingers into the list, or I don't know, I think that's actually what they're called. It's a weird word, though, I have to say. It always makes me a little comfortable saying it. But anyway, lists that maintain pointers or fingers into the middle of the list. Could you dynamically create more of those as the list went on? Yeah, absolutely. And that might be appropriate in certain cases. Sometimes, though, our goal is to pull, like, so for example, if you think about it, finding an item in a list is normally going to be ON. If I have 4 fingers into the list and I use them carefully, right, then I can, well, sorry, all I need, if I count start as 1 finger, right, then I should be able to find an item in the list in roughly ON over 4, right? Or maybe ON over 5, I'd have to think about it. Because I can, if I know what the index is, and I know where my fingers are, then the idea is I choose a finger carefully to get me to the right part of the list, and I start walking from there, right? And so let me think about it. If I have a list with 32 items, let's say I know where the item 0 is, and I know where item 7 is, and I know where item 15 is, and I know where item, what's the next, 23 is. If I'm looking for item 17, right, I know where item 15 is, so I use that extra into the middle of the list, and then I walk forward from there. And so on some level, the list is starting to feel like 4 separate smaller lists. And so my performance for a lookup is now going to be ON over 4. Does that constant factor, now in this class we would just say, oh, well, it's still ON, right? But for real applications, constant factors matter, right? There are certainly cases where making something twice as fast will get you a major raise, twice or 3 times or 4 times. So those type of, improvements can really help. So it's not, we're not always, completely, devoted to these really, really dramatic performance improvements. Sometimes adding constant factors to something can also be useful. And so I'm trying to look at the second half of that question. I don't know why my stream is, what's going on here? Okay, so that seems like it's fixed. Without explicitly creating them, so actually, if you think about it, what you would have, right? So imagine I have a list, and it gets longer and longer. And then I want to dynamically allocate these fingers into the list. Well, that itself is a smaller list, right? And so I could keep my fingers as a smaller list into my bigger list. And now when I need to find something, I first walk that smaller list, and then I use that to find the right place to jump into the bigger list, and I keep going. The trick there, right, is that rather than an ON walk, where N is this very, very big list, if I only, if I only keep a certain number of fingers, then it's a constant number. But if I keep, let's say I keep 1 finger for 32 elements, then I'm walking a smaller list to start, and that makes it smaller to get to, right? And so I think actually at that point, so let's say that I add a new finger every time I have 32 elements. I like powers of 2, clearly. So I have to walk that. I have a smaller list that's now size ON over 32. I have to walk that first to find the right finger. And then I jump into the bigger list, and now at most I have 32 more items to walk. And so the overhead of finding an item goes from ON to ON over 32 plus 16, right? Because that's the average number of elements I'm going to have to walk later. And so again, that's a constant factor, right? It's a constant factor of an improvement of 32 with the extra space overhead. So that's the other trade-off here. Those fingers take up space in memory, and so I have to have a place to put them. Yeah, and so they're super. Essentially on some level. Or the other thing you do is you can keep the fingers in an array, right? So if I have a constant number of fingers, then I really hate this term. Sorry, it's just weird to talk about fingers. It's like, anyway, no one's fingers will be cut off as part of this project. But If I have a constant number of fingers, then I just use an array internally to store them. And then the lookups are constant time. And so essentially, and we'll get back to this, actually, we're going to talk about maps in the future. And we'll show you again, we'll do kind of the same thing we did this time. We'll show you how to use maps that are built into Java, and then we'll show you how to implement one. And you know, there are essentially all of these interesting data structures that you'll meet in computer science. And a lot of them are kind of like weird blends of other data structures, right? So, you know, a simple linked list is its own thing. But then I can create a list-like data structure that uses an array and then also linkage. And so it's kind of like both. And you start to get these interesting trade-offs, right? So, you know, a list that has a constant number of fingers, or even if I have a number of fingers that expand, if I keep those in an array, I don't have to reallocate that array that often. And so there's all these interesting sort of trade-offs and games we can play here to kind of, you know, blend these different data structures. Have a data structure that sort of behaves like an array, but sort of behaves like a list. And that's actually what we'll see when we get to maps, right? Maps have this, one of the fun things about talking about maps is a common map implementation has this fun feature where it really does blend an array and a list. So, you know, there's this thing called the load factor, which we'll talk about when we talk about maps, where, you know, if I'm willing to waste a lot of memory, I can get something that behaves a lot like an array and has very fast lookups. If I'm not willing to waste as much memory, I get something that sort of behaves like a combination of an array and a list. And that's super interesting. So we'll get there. So the walk to, you know, so if you go through the question was about walk to, so go through the walkthrough about that how we remove what we actually have to do, right? In order to remove an element at a particular location, what I actually need to do is I need to make modifications to the element before it. And so I use that walk to function to walk the list to the item right before the item that I want to remove. And that's where I need to do my work. So that's the trick behind that. The walk to code's right there for you, right? So you can look at that. That's really what that is that's just the list walking code that we wrote previously. But what I've done is I've refactored that out because after we had implemented get and set, we saw the same code there. And as we were moving on to implement some of the other methods as well, we were seeing, you know, I didn't want to write that code over and over again. So it's pretty common in a linked list to need to be able to find a certain element. And so that's what that method does. So yeah, that's a great question. And I think if you go through that, and then, you know, the reason why we need the previous one, there's a nice diagram explaining that. Yeah, it's a good question. So the question about the MP, yeah. So the MP carries on. It's a multi-part project. So the first part is sort of making these small modifications to the existing starter code that we gave you. The next challenge will be more in depth, right? Because we've got you set up with Android Studio. You have some sense of what the code is that we've already given you. And in the next task, we'll actually show you how to create an activity and actually use it to display more detailed information about a single course. And then we'll connect that with the summary view, and we'll require writing some client-side and some server-side code as well. Yeah. So this is the single code base that we'll be working in for the rest of the semester. Maybe you like that answer, maybe you don't like that answer. But you know, the reason why we do things this way is I think that there's a certain amount of time and investment that you place into understanding how a particular code base works, and I want you to be able to leverage that. In the past, we've done smaller assignments that were disconnected from each other, and to be honest, that's also pretty weird. It's just not something that computer scientists do, right? I mean, when you write code, you typically have to live with that code for weeks, months, years sometimes. I mean, I'm, you know, going back now and revisiting code that I wrote almost exactly a year ago, and I've been maintaining ever since. So it's a, you know, to the degree that we try to prepare you for real software development tasks, picking up a project that someone else has prepared for you, working on it for a week or 2 weeks, and then never touching it again, just never happens. as just a super weird thing to do. I mean, maybe like a hackathon or something, but even in a hackathon, you probably start from scratch, right? And the other thing too with Android is that Android is, we've tried to set up this project so that I really actually do want you to understand as much of it as possible. In the past, there's this tension because as we try to do something that's more interesting, and maybe you think the MP is not particularly interesting, and I think that's a fair criticism, but as you try to do things that are more interesting, what happens is we end up having to give you more and more and more code to start with, because some of these things are actually pretty hard to figure out on your own, and we don't expect you to do that given the level that students come into this class and the amount of time that we have. And so there's some trade-off there, right, where we're trying to kind of find a sweet spot between giving you a lot of code so that we can do something cool, but then you never understand it, versus doing something smaller, giving you less code, and really expecting you by the time you're done to understand a lot of what's going on. So that's kind of that's where we're trying to find that sweet spot. It helps to be able to work on something for a longer period of time, right? So for example, some people, there's quite a bit of documentation already available on the MP about certain parts of the project. People may be wondering, well, why is that there, right? I didn't have to modify the server, I didn't have to modify the client. You will. That's coming. So the next stage of the MP, you will have to write both. You will have to make changes to both the client, the server, and the front end. Again, one of the goals behind the project is to teach you, or at least model, kind of how you might work on a larger project. Side project, you might start on your own. Larger project, you might need to pick up in a class like 126 or downstream. And this is kind of a pretty normal way to get started on something. Again, it's a small piece of starter code. A lot of times, like if you went to work for a software development company, I've had really, really talented software developers that I've worked with in the past, that have done, PhDs with me, that have gone off to, to large tech companies, and they spend months just understanding the project that they have to work on, right? It's not like you get hired to work on, I had a guy who's working on Chrome, right? You don't get hired to work on Chrome, and it's like you sit down the first day and you bash out some new feature. No. It's like months and months and months of like finding your way around and figuring out how stuff works and, grappling. And even then, you're not going to understand the whole thing. You're just trying to focus on understanding the parts that you need to work with and you need to modify. And so, if you think about the stages, or well, you guys don't know this yet, right? But the stages that this MP goes through, the first part is largely concerned with you guys getting a development environment set up, getting comfortable with the process of making changes to the code, testing things, submitting, which we'll get to soon. And then, but the first part doesn't really require you writing that much code. Next time, you'll have to do more. But at the same time, the code that you write is also going to look a lot like code that's already there. And again, that's another really common thing to do, right? Is when you start up with the project, you make some small changes at the beginning, and then the next thing you do, they'll be like, oh, add this feature that kind of works similar to this other thing that's already there. And you're like, oh, okay, I can see there's code that does this. And to be honest, like mimicking code that's already in a project is actually a really, really good way to build things, partly because the people that wrote it have a particular style of doing things, and they want you to do the things the same way so that it doesn't hurt their brain, right? If you got 5 different developers that have 5 different ideas about how to do stuff, it becomes a mess, right? So part of learning how to program in a team or in a mature software development context is kind of learning how to subvert your own style to the goals of the project, right? So you see how things are done, and it's like, okay, they must like doing things this way. I'm not sure I agree with it 100%, but they've asked me to do this new thing, and I'm going to make it look like the other parts of the project. So that's what we'll do next. Assuming the test we provided isn't an exhaustive list of checks for final grading. It is. That's well, I shouldn't say that. The test suite that we gave you is what we use in final grading. It's the same set of tests. So there's no hidden tests somewhere that we're going to run. We don't do that in this class. Later classes sometimes like to play those games. I think there's times when it's appropriate. for us, I think it's more important to be transparent and also for you to have confidence in your score before you actually submit things. There are ways to break stuff when we do final grading, don't get me wrong. And that's why there's a process where you can see your grades and things like this, and we'll get that up and running over the next few days. But the process of grading locally is the same process that we use remotely, so we don't have any hidden stuff. That said, I'm not going to argue that the test suites that we gave you are exhaustive. They're not. This is another place where we've had to kind of, there's another sort of balance here, right? So when you're writing test suites for grading, there's this temptation to write these really awful, nasty test suites, right? That test every possible corner case and all these weird things and stuff like that. And that's fine, I guess, but what I wanted to show you are test suites that look a lot more like ones that I might write if I was actually building something for real. So I think my point is that sometimes when people write test suites for grading as part of an assignment, they go a little nuts. And the test suites that they create are not really representative of what you would find in a real project. Are these test suites perfect? No. There's probably corner cases, edge cases in there that I haven't anticipated. And the other thing too is that their limitations are also connected with the fact that you guys are only working with a small amount of data right now. And later on, as we get towards the final project component of the project, some of you may want to work with a larger data set, and I can certainly provide that. I have the equivalent JSON files for every course at the university, and I can certainly provide those to you if you want. Or at some point, we maybe get around to setting our own backend that you can connect to that will observe the same API that you guys are being asked to write locally, but will also do things like allow us to support other semesters and stuff like that. So at some point, if you wanted to, and maybe we'll have this, again, be something that people can do as part of their final project, you could connect your app to our backend, and then you could get rid of the server component and those local JSON files, and you could be pulling data actually from our server. I didn't want to do that as we got started because I wanted you guys to see how to write that part, right? Because I think that's actually pretty cool, right? So you guys get to write both sides of the web API right now, which is neat. And something that you might, like if you were building a small project like this, you would do both, right? You would be writing the code that runs on the server, and you would be writing the client. And so making decisions about how those two work together is an important thing to see, and also just to see both parts, because there's no magic here, right? It's just code. So again, the test suites aren't perfect. I think if you loaded in a larger data set, you'd find some things that were probably not, you'd probably find some bugs with your code that we haven't caught. Let's put it that way. The test suites are probably not perfect in the sense that I think they're testing the things that we want to test, but they may be missing cases that you would see if you use more data. And so that's really, but again, they're really designed, they're designed to look more like the test suites that you would write in the wild. One of the things that we don't teach in this class, and maybe we will someday, but we just haven't found a good way to do it right now, is to teach you how to write test suites for a real product. That, to me, is probably one of the most kind of underappreciated, undertaught skills, software development skills. I mean, that's how real people build real software, right? I mean, whenever I want to add a feature to something, whenever I find a bug in one of our tools, the first thing I do, and I'm not kidding here, I mean, this is actually for real, the first thing I do is write a test. Usually it's easy because I have like hundreds and hundreds of tests already that are sitting around in the project, and I can usually just modify one of them slightly, right, to do what I want. But I write the test suite, I get it to fail, because it's failing is now a positive control. Because when you're building, here's the problem, when you're trying to build a new feature into something, it's hard to know, like, am I done? Does it work, right? And so I write the failing test case, and then when I'm done, I know it because it starts to pass, right? So usually I write one test case, I just run that test case, and I'll just run it over and over as I'm developing, right? Until I get to the point where it passes. Then turn on the rest of the test suite, which for some of our projects now has hundreds, dozens, tens, hundreds of other tests, and I run the whole test suite just to make sure I haven't broken anything else. Because sometimes as you're developing, fixing one thing, you end up breaking something else, and then you have to go fix that or whatever. But driving your development through tests is an incredibly psychologically healthy way to do things. I mean, programming is hard. I mean, you guys are I think, are experiencing that, and it can be super frustrating. Writing tests and leading with the tests is just, I mean, it produces that, the feeling you guys get when it's like you pass all the test case, you're done with the homework. Like, I get that feeling, right? And I like that feeling too, right? When it's like, oh, okay, this thing's broken, I finally got it to work, I feel good about that. So that's how, this is how real software development works. And part of the reason for it is that it's a very productive way to work, but it's also very psychologically healthy, right? It's fun to watch things pass. It's fun to know that you're done, right? It's fun to not have a fear in your heart every time you deploy something that something's broken, right? I mean, and when you don't have test suites and when you don't develop that way, you're always flying by, right? And I do that sometimes in certain things because it's harder to test or because I've had to rush things out, but I never feel as good about those projects as I do about the ones where I have lots of tests, right? And so I know, and as you write more tests, it gets better and better and better because you know more and more about what the project's supposed to do, and it just makes it even more exciting and even more comfortable to build new things. Corner test cases, yeah, I mean, part of this is, as you continue to program and build stuff, you'll start to remember, right? You'll start to remember, right, that didn't work right, or that thing is broken, or remember that one time that thing happened and it was weird. And so you start to build up kind of like it's this, I guess people say that humans tend to remember pain, right? So you kind of like, you build up a library of mistakes that you've made that you remember. And usually you don't remember them after you make them once. You remember it after you make them like 50 times. And at some point you start to, and not every mistake is applicable to every problem, but depending on what you're doing, you have this like, oh, okay, that could probably be the problem, right? And you start to write test cases that way, right? And that just comes with experience, right? I mean, doing this a lot, making a bunch of mistakes, learning from them, and then there's something meta about it, right? Where it's like you actually have to be, there's something there's this, thinking about thinking, right? Metacognition, thinking about the ways that your own thinking can go wrong, right? How can I mess this up, right? What are all the different ways that I can potentially bork this, right? And those you start to get good at those. The other thing that people do though, right, including me, is they start to program very defensively, where they, those assertions that we've been using, you use equivalents of those as you're going, right? And those are good ways to test things as you're going, so that, if I'm assuming that this variable is not null, or I'm assuming that this list has at least one element, or I'm assuming that I'll be able to find something in this list that I'm looking for, or whatever, you test those assumptions using those assert type statements, and that really helps as well. So that's pretty good. Again, so as far as Android development is concerned, I will admit that I'm not an expert. I do a lot of development. Most of it's not Android. It's just not. It's the stuff I work on tends to be stuff that's class related. And even though we do Android MPs, we don't really have any Android tools that we maintain for this class. And so, yeah, I mean, it's a great question. I'm not sure about that. I mean, one of the things that we are doing in this MP though is one of the things we're doing is we're trying to model best practices for how to test stuff. And there's a framework that we're using. This is something that's actually now included as part of Android. So one of the biggest difficulties whenever you're testing like an app, something that interacts with the user, is actually testing the interaction parts, right? And so it could be a website, it could be an app. Testing that turns out to be really hard. You can test lots of, so one of the things you do, or you try to do when you build things, particularly when you're building interactive stuff, is you try to architect the system so that you can test it without having to type on it, without having to touch and do. If you have to do a lot of manual testing by clicking around the app and stuff like that, that actually, that's not a particularly good way to do testing. So there's two strategies here, and I think the app is a pretty good example of both. One is, it's hard to explain this. One is to not have your UI interaction parts be as simple as possible. So usually what you want is when someone clicks a button, you want that to call some other function, because then I can test that method without clicking the button. If the button click handler does all sorts of stuff, right? And if I could take that whole method and I could put the code inside the event handler, right? That callback for the button click. We'll get here. We're going to do this for the next part of the MP. We're going to have you guys actually handle a button click. So if that so that's tough to test. However, it is testable, and one of the tools that we're using as part of this MP is a tool that actually allows you to do that. So this is a framework called Roboelectric. Android has a way to run tests on the emulator. So there's this whole approach where you can basically script. So there's a way in Android, and we don't use this because we don't want to run tests on the emulator because the emulator is really slow. And we want to be able to run eventually the way that we're going to grade your assignments is we're going to run your code in our cloud in a controlled environment, and we don't want it to take like 10 minutes and to consume a gazillion cycles, and the emulator is extremely slow. And so without getting into too many of the details, which I don't fully understand myself, Android has come up with a way of sort of, I guess it's not emulating, simulating Android and some of the events. So if you look at those end-to-end tests that we provided you with, those do things like they launch an activity. They have a way of waiting for it to finish drawing the UI, and then they can actually test things about the UI. So for example, we test to make sure your courses are sorted in the right order by looking at the first course and the last course. We test to make sure that they're displaying certain information on the screen by looking at the text that's shown, right? We'll continue to do this in the next part of the MP where you guys are going to build your own activity. That is super powerful, right? And that's another tool that you have in your belt. Now, those tests are slower than the other type of tests that we provided, and they're on some level they're harder to write. And so, like I said, whenever you're testing anything with the UI, you really have to. It's hard. Let's just put it that way. There's a lot of work that goes into architecting the system so that it's easy to test, and then actually figuring out how to test it. To be frank, in certain environments, it can, you can end up not having a test suite for this reason, right? Like big chunks of the website, no test suite, right? Because it's just, simulating the interaction with the UI components turns out to be really, really tough to do, even in a web context. And Android has some good tools for this, but I think that's probably the biggest thing about any type of Android or any type of front-end development where you're building something that interacts with the user is, as you work on projects like this, what you'll find, like if you went to a company that maintains a popular Android app, like Facebook or whatever, what you would find is that not only have they architected the code very, very carefully so that they can test as much as possible of the logic without needing somebody to click on stuff, but they've also built those end-to-end tests as well, right? The test common flows, like I should be able to log into the app and what's the first screen that's shown, and if I click on one of the items in my news feed and click on the like button, something should happen, right? And they'll have those tests as well. But those tests are harder to architect. And it turns out, this is, sorry, I know I'm sort of went off on a tangent here, but it's kind of it's a fun topic. You end up when you write any type of software, but this is particularly true, I think, when you write apps and other user-facing tools, you'd be surprised at how much time and energy goes into supporting testing. It is, I think sometimes people think, well, I write the code and then I write tests for it. No. Like along the way, the people that have written the code have spent a huge amount of time designing it, building in various places so that the testing is easier, and you end up spending a lot of time designing the code so that it can be tested, because the testing is so valuable. That's the real reason, right? I mean, I know you guys are reading Coders and you guys are reading about the wild days of Netscape when they would just throw shit up on the wall and see if it stuck. Nobody does that anymore. Not the big companies. I mean, people still do it, like small little scrappy startups that are just, that are building, new features every day. Will just get something to work and then wait for it to break in front of some user and hope that it doesn't happen when you're, presenting to some sort of VC and trying to get a round of funding completed. But the big, well-established companies with big apps, they do perform experiments on users. Don't get me wrong. But the experiments aren't, does the app break or not? The experiments are like, will more people click on this if it looks this way versus that way, right? There's a lot of that actually goes on. Some of you should do this for some point, like, if you're hanging out with friends. I don't know if people use Facebook anymore, but if you get 3 or 4 people to open Facebook, usually it depends, on kind of what they're trying, but it's not uncommon for you to be able actually to notice differences in the UI, even between a couple of different accounts. And that's because they're always trying these little experiments with, do people stay on the site longer if the login button is on the left versus the right, or this color or that color, and it's all this. So there's really not one version of the site at any given point. There's a bunch of different versions, but they're doing this with working versions to test out different layouts or different interaction patterns. They're not being like, hey, users, try this version because we think it's buggy. I mean, given how complex some of these tools are, it's actually pretty surprising they're not more broken than they are. And the reason is that they do all of this testing before anything goes live. All right, long answer to that question. On the other questions about Android stuff, about today's mirror, I can't tell from Ben's question whether or not that was the answer he was looking for, or whether or not he was hoping that we were going to be doing something else. This is a simple app, right? I'm not going to deny that. I would also say that the design patterns that we're presenting in this app are incredibly common. So fetching data from an API, every app, I shouldn't say every app, many apps do that. Rendering lists and detailed views and stuff like that, many apps do that. And so I was just, talking about this with a colleague, and I said, we could take this app and we could mod it so that you were looking at different items to purchase at a store, right? Or if you're looking at different biological molecules, and you could click on them and get a detail of how they were synthesized or whatever. I mean, this type of summary and detailed view that you guys are going to finish up over the next month or so is a really, really common app design pattern. And so I think, my goal, my hope, my desire with the MP is that you learn some common programming app development patterns and design principles that you can then go to apply to some other problem. Because, on some level, like, what differs between these problem domains is just kind of like the data and how it's interpreted, not really some of these patterns of interaction and where data comes from and stuff like that, right? And so there's some really, having built a lot of web apps, having built, I do a lot more web design than I do app design, but the principles on some level are very similar, right? I mean, you're fetching data and then you got to make it look a certain way and handle user interaction. And so if you can start to learn some of those patterns, you can probably apply them to a lot of other things that you might want to build. Not everything follows the same pattern. I mean, the games sometimes are a little different, right, in terms of UI. But yeah, but we'll get there. I think that you guys will have fun with the next couple parts of the MP. I know that again, it's not like world's most exciting application, but that's okay. The point here is to learn these programming principles, and the fact that you guys are doing full stack stuff, right, is pretty cool. Oh yeah, so we'll deal with that. Yeah, students that don't finish a certain part, particularly for this part of it, we'll probably, we're basically just going to be able to kind of walk them through it pretty quickly if they need to as they go forward. But yeah, no, I mean, it does build on itself. That's for sure. But this semester, our plan is to kind of, try to give people enough time to do things, support them as well as we can. And if they don't quite make it, we'll have maybe some review sessions that they can attend where we'll just kind of walk through how to do stuff and cobble together enough that you can get up to the next chunk. If we have to hand out some code, we could do that as well. It's not the end of the world. All right, other questions before we break for the day? Fall is definitely upon us, it seems, after a little bit of late summer. So far too, I'm going to look this up while we're talking. I was pretty happy last time I checked on the numbers of students that the kind of where people were getting in the MP. The official grader is not online yet, but I've been using here we go. I've been using when you guys run that that local auto grader, that phones home and sends us a little bit of data. And based on that, it looks like people are doing quite well at kind of definitely getting through getting through this checkpoint. And it looks like quite a few people are actually done, which is good, at least given where we are. And people have more than a week left to wrap up. But it looks like a good chunk of the class has been able to get to the early deadline. I'll have to figure out. Let's see here. Yeah, so it looks like 20% of the class is done with the first checkpoint, which is great. And how many people have gotten any points at all? That's slower. Yeah, definitely got people. People always kind of waiting for the last minute to start. That's okay too. All right. I'll stick around for a couple more minutes just in case people have any final closing thoughts. Next week, we're going to talk about, we're going to move some material around this semester, so we'll go a little bit of a different order, but my plan next week is to talk about maps. So this is another one of these just core data structures that is both fun to talk about, and then we'll actually have a chance to implement one together, which is also super fun. And then I think we'll also do a couple of lessons on web APIs, because that's something that's coming up for the next MP checkpoint that I want people to feel comfortable with. And so those two topics, kind of moving them up now, will give us a chance to, prepare the ground, I think, for the next part of the MP. And then at that point, we'll probably go back and talk about trees and recursion and knock off. I mean, between now and the end of the semester, the big core topics that we cover are maps and hashing, because hashing kind of goes along with that. Hashing's super fun. The internet API, web APIs, and then we do a good chunk on trees and recursion. That'll take us the better, probably an entire week, maybe a little bit more, and then a big chunk on sorting algorithms, which are both fun to implement and also fun to analyze. So those will give us a chance to sort of stretch our, kind of push our capabilities in those areas. So yeah, that's all downstream. But I think moving the maps and internet stuff up, web API components up, will really help people make sure that they see that material, because you can already see a couple places in the in the backend server for the MP where we're using a map. And we'll also, you guys will need to use that a little bit more explicitly for the next part of the MP. So, all right. Hope you guys have a great weekend. Keep in mind, there's no weekend homework this weekend. I expect you to use that time to get started on the MP. Good luck with that. And I'll have details up about the submission process soon, probably tomorrow, if not Sunday. If needed, we'll push the deadline back for the early deadline a little bit to accommodate that. That's not a problem. But that should be working soon. And I will look forward to seeing everybody on Monday. So Monday we will have a lesson. Next week will be Monday through Thursday with the lessons. Friday, we'll take a break, let people focus on finishing up the MP. And then we'll have the new part of the MP for MP1 released on the following Monday. So also keep in mind, midterm next week on object-oriented programming, and I'll post something about that as well. All right, hope everybody has a great weekend. I will see you on Monday.